Polynomials look like a fancy term, but hey, they're not at all complicated. Just take some real numbers. Now multiply them by a variable which has been raised to whole number powers. What you get are known as individual terms. Now add these terms together. What you get is a polynomial expression. Isn't that easy? Let's talk about the individual terms for polynomial. So let us just assume that we have the rth term of a polynomial. So the rth term will be represented by a with a subscript of r into x raised to the power of r. Okay, now here what is the coefficient? So the real number part of the term is known as the coefficient. So suppose we have something which is 3x square. So here what is 3? 3 is going to be the coefficient. So for this term, what is the coefficient? This AR is going to be the coefficient. Next we are going to talk about the variable. So here the name of the variable is x. So what is the variable? Variable is going to be the unknown part of the term. The variable could have other names as well. You could represent it by y, you could represent it by z, you could have one variable or a combination of variables. But here in this chapter, we are just going to talk about terms which have only a single variable x. So that is what the scope is for this lesson. Next, we're going to talk about the exponent. Now, here the exponent of this variable is r. So what is r? R is the exponent or the power of the variable, and this r is also known as the degree of this particular term. So r is known as the degree of the term. Now here we have only one variable, so the degree is going to be the exponent of x. But suppose we had a combination of variables. In that scenario, we have to add up the exponents of both the variables. Suppose we had a term which says x y square. So here x has a exponent of 1 while y has an exponent of 2. So the sum of these two exponents is going to be 3. So here we can say that what is the degree of this particular term? The degree of this particular term is 3. Okay, now we are going to talk about the restrictions which are present for each of these coefficients, variables, degrees, etc. So let us talk about our coefficients first. So the coefficients have to be real numbers. So the coefficients have to be real. So what does this mean? This means that if I have a term which says pi x square, is it valid? Of course it's valid, because here this is going to be the coefficient pi. Now pi is an irrational number, but it is a real number. So this is a perfectly valid term. Another example could be like I could have 1 by 3 x squared. Now here, what is the coefficient? It is this 1 by 3. Is 1 by 3 valid? Yes, of course. 1 by 3 is a rational number, so it's definitely valid. So this is a perfectly valid example as well. Now let's talk about another example. Suppose we have something like under the root of minus 1 x. Is this valid? No, this is not valid. Why is it not valid? Because minus 1 under the root is not a real number. So what is this? This is also known as iota, and iota is a complex number. So that's why this is not going to be a valid term. I hope you've understood the meaning of the coefficients being real. Now, let us talk about the degree. Now, when we talk about the degree, we say that the degree of this term has to be a whole number. Okay? So when I say that the degree has to be whole number, so that means x raised to the power of 1, x raised to the power of 0, x raised to the power of 5, anything. These are going to be all valid. But if I say that I have a term which says 3 by x, what does it mean? It means that what is the power of x here? Now x has a power of -1. So is -1 valid? No, it is not. So this is not a valid term. Now let's talk about another term. Suppose I have something called 3 under the root of x. Is this a valid term for a polynomial? Now let us just examine this. So here, what is the power to which x is raised? So the exponent here is going to be half. Is half a whole number? No, it is not a whole number. So is this a valid term? No, this is not a valid term because x is raised to the power of 1 by 2. So the exponent is 1 by 2. 1 by 2 is not a whole number. So definitely this is not valid. I hope you have understood what individual terms have to be like. Let's identify coefficient, variables, and degree for some terms. Now the first term is 3x raised to the power of 2. So here, what is the coefficient? Coefficient is the number part of the term. So what is the coefficient here? The coefficient is going to be 3. What is the variable? The variable is represented by x. The name of the variable is x. X is the unknown part. And what is the degree? The degree is the exponent of x. So what is the exponent of x here? It is 2. Okay, now we come to the next question. Now, in the next question, we have just been given 6. So we have a term which is represented by 6. So what is the coefficient here? Coefficient is the number portion. So what is the number portion here? It is 6. So the coefficient is going to be 6. What is the variable here? We don't know the variable here. So it could be anything. Depending on, so we can just give it a name, suppose x or y or z, anything. So we don't know that. What is the degree of this particular variable? What is going to be the degree of the variable? The degree of the variable is definitely going to be 0. Why? Because anything raised to the power of 0 is 1. So we could represent it as x raised to the power of 0 or y raised to the power of 0 or z raised to the power of 0. Everything, all these things are going to be equal to 1. So we don't know what the variable is here for this particular term, but we know that the degree is definitely going to be 0. Now we come to the next question. The next is x. So we have x. So what is the coefficient here? Now, coefficient here is going to be 1 because if there's nothing written in front of x, that means it is 1 times x. So the coefficient here is going to be 1. The real number part is going to be 1. What is the variable here? So the variable is going to be x. And what is the power of this variable, or what is the exponent to which x is raised? The exponent or the degree of this particular term is equal to 1 because if we just write x, that means x is raised to the power of 1. Now that we have looked at the individual terms, let's see what a polynomial expression looks like. So here we can see a polynomial expression which is represented by an x raised to the power of n plus an minus 1 x raised to the power of n minus 1 and so on and so forth until we reached the constant term a naught. For a polynomial expression, we have something called the leading coefficient. So what is the leading coefficient? Now leading coefficient is the real number which is in front of the variable which has the highest power. So first we have to locate the term which has the highest power, and then the real number in front of it is known as the leading coefficient. So let's see an example. Suppose we have a polynomial expression which says 3x squared plus 5x plus 1. Now in this polynomial expression, which term has got the highest power? Okay, so here we can see that this is the term in which the variable has got the greatest exponent, which is 2. So this term has coefficient which is known as 3. So what is the coefficient here? It is 3. So this is going to be the leading coefficient. Now this leading coefficient is very important because the sign of the leading coefficient is definitely going to determine some characteristic about the polynomial. So when we see the graphing of these polynomials, then we'll find that this and the sign of this particular leading coefficient is going to determine certain features of our polynomial curve. The second thing here is what is the degree of the polynomial. This term has x variable with a degree of 0. This term has an x variable with a degree of 2. So what is the highest degree? The highest degree is going to be 2. So that is why the entire polynomial expression will have a degree of 2.